Hello everyone, we're going to continue our discussion with exponential functions, and we just talked about exponential growth and decay. The next thing that we're going to talk about is the most important exponential function, and maybe some of you guys can guess it, but it's f of x equals e to the x. Now e is just a number. Perhaps you've heard it before. There's this amount equals principal, the exponential number to the RT, and maybe you've seen that before when you were trying to find interest in how much the rate was and then the time. So that E value is the same E value that we have over here. And now, formally, we're ready for this definition. Now, whenever you see E, you might have known that it's a number, but you weren't able to know specifically what the number was. And now, with our knowledge with calculus, we can actually define it. We're actually going to have the limit as x goes to 0 of 1 plus x to the 1 over x, and that equals the number E, and that's an official definition. So wow, it took you most of your mathematical career to get to just what the definition is of what E is. Alright, so we're going to try to figure out what E is specifically, the number, and we're going to try to figure that out using a table. So here we go. We're going to substitute in 1 over 10. And so that's 1.1 to the 1 over 10. Oh, to the 1 over 1 over 10. So it's just 10 here. And if you put that into your calculator, you get 2.5937. Okay, and then we can get even closer, so maybe 1 over 100. We get 1.01 to the 100, and then that's going to equal 2.70481, and these numbers keep on going. Let's do one more. If you do 1 over 1,000, you get 1.001 to the 1,000, and you get 2.716923. So you continue on and you're going to get closer and closer to what the value is for E. And E, if you look it up, is 2.7182818, and it continues on forever and it never repeats. And so this is our number E, and we have found exactly what the number is. So with that, we want to graph. Y equals e to the x. We're going to do that with our table like we were doing before. So let's switch it up and actually do some different numbers. So let's do 0, 1, 10, 100, and then -1, -10, -100. E to the 0 is 1. E to the 1 is E, which is approximately 2.71. E to the 10 is, shockingly, 22,026. So you can see that it's growing. E to the 100 is 2.68 times 10 to the 43rd power. So it's really big. We got 1 over E when we substitute in -1 is, well, seems like I haven't calculated that. So this is a good time to challenge yourself and see if you can get the answer too. So here we go. We got 1, nope, 1 negative. There we go. I got 0.3678. So smaller than 1. If we got e to the 1 over e to the 10, that's going to equal 0.00045. Keeps on going. And then so on and so forth. So let's actually graph this. At 1, it's at 2.7. At 10, it's way up here. At -1, it's at 0.3. -10, it's 0.00. And we see that we got this exponential growth. Alright, we can also notice that the limit as x goes to infinity of e to the x is infinity, and the limit as x goes to negative infinity of e to the x is 0. So we still get that horizontal asymptote at 0. Okay, so hopefully we can figure out some generic things now, and that would be so if we have a is a positive number and a doesn't equal 1, then let's consider our function a generic exponential function. Yeah, so a is a constant, x is the variable. That's why it's an exponential function. Okay, number 1, if a is bigger than 1, then do you think we have an exponential growth or decay? It is going to be growth. And whenever we have exponential growth, the function is increasing. So if we go to take the derivative, we would get that it's positive. Okay, number 2. If a is between 0 and 1, then our exponential function is exponential decay. And in that case, decreasing. One more item. Got if a x1 equals a x2, so the base numbers are the same. Then, wonderful property of exponential functions, it says that your exponents have to be equal. Alright, that'll do it for this one. I'll see you in the next video. my computer, my laptop froze again. So I'm just trying to stop it. Just trying to stop it. Just trying to stop it. Here we go.